Question 1. Hybridization of oxygen in this is dash AsP, BsP2, CsP3, DsP3d. So over here we see the oxygen is connected by a double bond with carbon. From this one bond is the sigma bond and another bond is my pi bond. There are two bonds, it's a double bond. Therefore, the hybridization will be sp2 hybridization. Option B, sp2 hybridization is the correct answer. Question 2. Which of the following functional group is common to aldehydes, ketones and carboxylic acid? So if I draw an aldehyde, it's an R which is connected to carbon with a double bond O, and over here I will have an H. Whereas in the ketone, instead of this H there will be an R. So this is R, C, R and double bond O. So here if we notice C double bond O is there in both aldehydes as well as ketones. Therefore option B is the correct answer. Question 3. According to IUPAC system, dimethyl ketone is known as dash A acetone, B ethanol, C ethanol, D propanone. So as I draw dimethyl ketone, so this is my carbon, these are two methyls joined to it and I make it as a ketone, and I have eliminated hydrogens for now. I am just making the carbon chain. Now if I calculate the number of carbons in my longest carbon chain, it is 3. So this will be propane. 3 is propane. Since it is a ketone, it would be propanone. If it would have been an aldehyde, it would have been propanol. But it's a ketone, therefore it would be an propanone. Option D, propanone, is my correct answer. Question 4. According to IUPAC system, acetaldehyde is called as A methanol, B ethanol, C propanol and D ethanol. So over here, if I have to draw acetaldehyde, it is this double bond H. So over here my longest chain is of 2 carbons, and since the longest chain is of 2 carbons, it will be ethane, and since it's an aldehyde, it's ethanol. Option D, ethanol, is my correct answer. Question 5. Common name of this is A ethyl isopropyl ketone, B isopentyl ketone, C ethyl propyl ketone, D propyl ethyl ketone. So over here let's make this, let's draw it again, eliminating the hydrogen so that we get a proper carbon chain. It is CH3, I make a C here, CH2. Now this C of mine is attached to an oxygen, so this will be my functional group. Again it's a C, and now this C is attached to 2 methyl groups, so it will be 2 methyl groups attached to this C. The same thing I have drawn over here, eliminating the hydrogens. So now I know this is my functional group. Now we'll check out what all is attached to my functional group. Over here I have an ethyl group attached to the functional group, and over here I have an isopropyl group which is connected to my functional group. So if I make a name out of it, it will be ethyl isopropyl. And it's a ketone because the carbon is not attached to any hydrogens, it's attached to both the carbon. So ethyl isopropyl ketone. This matches with option A, ethyl isopropyl ketone. Therefore option A is my correct answer. Question 6. The reagent used in Gattermann-Koch aldehyde synthesis is A PbBAsPb BaSO4, B alkaline KMnO4, C acidic KMnO4, D CO plus HCl. In Gattermann-Koch we have carbon monoxide, CO and HCl. Therefore option D, CO plus HCl, is my correct answer. Question 7. The CC double bond O and the O double bond CO bond angle in carboxylic acid is A 120 degree, B 90 degree, C 150 degree, D 100 degree. So if I make, this is my functional group and this is my carbons or hydrogens attached to it. So now all these 3 angles between this bond and this bond, between this bond and this bond, and between this bond and this bond, all the 3 angles are 120 degrees. This is 120, this is 120 and this is as well as 120. So all the angles of this and this will be 120. Therefore option A, 120 degree is my correct answer. Question 8. Which of the following is used for silvering mirrors? A. Benzaldehyde, B. Benzoic acid, C. Formaldehyde, D. Formic acid. The correct answer is option C, formaldehyde. Question 9. Which of the following will not give the positive tests for aldehydes? A. Wirth's reagent, B. Fehling solution, C. Schiff's reagents, D. Tollens reagent. Except Wirth's reagent, all the reagents or the solutions will give positive tests for aldehydes. Therefore, A. Wirth's reagent will be my correct answer. Question 10. Lower aliphatic carboxylic acids are dash. A. Colored liquids, B. Colorless liquids, C. Vase-like solids, D. Gases. The answer is B. Colorless liquids. Option B is the correct answer. Question 11. When acetic acid is heated with P2 at P2O5, it gives A. acetyl oxide, B. acetic anhydride, C. acetyl oxime, D. acetyl amide. So over here, first I will make acetic acid, that is CH3COOH. For the reaction purpose and balancing, I will twice it, and I will have its reaction with P2O5 as given in my question. I will heat it. This will form acetic anhydride. What is acetic anhydride? Is C double bond O. Now this has an O in the middle, and this is again attached to a carbon with C double bond O. With my CH3 and my CH3. This is my acetic anhydride, and plus it will give out water. Option B, acetic anhydride, is my correct answer. Question 12. Formic acid is used in A. Rubber industries, B. Manufacture of leather, C. Textile industries, D. All of these. If you see the uses of formic acid, it is used in all A, B and C. Therefore option D, all of these is my correct answer. Question 13. Urotropine is a dash. A. Primary amine, B. Secondary amine, C. Tertiary amine, D. Quaternary ammonium salt. Option D, quaternary ammonium salt, is my correct answer. Question 14. Which class of compounds show H bonding even more than in alcohols? A. Phenols, B. Carboxylic acids, D. Ethers, C. Ethers, and D. Aldehydes. Over here, carboxylic acids, B is the correct answer. My phenols is my dash OH group. When it comes to carboxylic acid, I have COOH, ethers, and aldehydes. Out of this, carboxylic acid has the strongest H bonding. Therefore, option B, carboxylic acid, is my correct answer. Question 15. Which aldehyde is insoluble in water? B. Propanol, B. ethanol, C. butanol, D. heptanol. Propane has 3 carbons, ethane has 2 carbons, butane has 4 carbons, and heptane has 6 carbons. Over here, the 6 carbons is my higher aldehyde, and higher aldehyde will be insoluble in water. Therefore, D. heptanol. Heptanol. So it is my 7 carbons. Hexanol is my 6 carbons, but heptanol is my 7 carbons. It's my higher aldehyde, and therefore it will be insoluble in water. Therefore option D, heptanol, is my correct answer. Question 16. IUPAC name of CH3CH2COCH3 is dash. A. Butane 2-ol, B. Butane 1-al, B. Butane 1-on, D. Butane 2-on. The same thing we will represent by eliminating hydrogens and just showing the carbon chain. So this is CH3, CH2, C double bond O. This is my functional group, C double bond O, with this as CH3. Now if you see, this is my functional group. If you count by the longest chain rule, the longest chain is of 4 carbons. Therefore it will be a butane. By the shortest number rule, this is my first carbon, this is my second carbon, so this will be my butane 2. And it's a ketone, so it will be butane 2-on. Therefore option D, butane 2-on, is my correct answer. Question 17. IUPAC name of the compound. This is A. 2-methyl propane 2-al, B. 2-methyl propane 2-on, C. 2-methyl propanol, D. 1-methyl propane 1-al. So if the same compound I write by eliminating H's and only showing the carbon chain, this is my C, this is this C, this is this C, which is attached to oxygen and then hydrogen. Over here we notice one thing, that my functional carbon is attached to oxygen and then hydrogen and not any other carbon. So this is my functional group for aldehyde. So it won't be a propane, it will be an aldehyde. Over here I have another methyl over here. Okay, now if we just see the longest chain, this is my longest chain. So it is my propane with an aldehyde. So it will be a propanal. And on my second carbon, there is a methyl. So on my second carbon, there is a methyl, 2-methyl propanal. 2-methyl propanal, option C is my correct answer. Question 18. Formaldehyde is obtained on commercial scale by the oxidation of A. methanol, B. ethanol, C. ethylene, D. formic acid. Formaldehyde on commercial scale will be obtained by methanol. Option A is my correct answer. Question 19. The IUPAC name of alpha methyl butraldehyde is A. pentanal, B. 3-methyl-butanal, C. 2-methyl-butanal, D. methyl-butanal. So here first we'll make what is given in the question. They have just given the name. We'll make the structure of it. So this is CH3, CH2, CH, CHO. And on the alpha, this is my alpha carbon. On the alpha, I have a methyl group. This is my CH3. So this is my 2-methyl-butanal. 2-methyl. On the second carbon, I have a methyl. And it's a butanal. Why? Because the longest chain contains 4 carbons. This 2-methyl-butanal is also, this is the IUPAC name 2-methyl-butanal, which is also known as alpha methyl butraldehyde in its common form. So this is the IUPAC name is 2-methyl-butanal. Option C is my correct answer. Question 20. Methyl N-propyl ketone has IUPAC nomenclature as A. pentane 2-one, B. butane 2-one, C. pentane 3-one, D. butane 3-one. So first we will make the structure of methyl N-propyl ketone, which is asked in the question. So it is CH3, C double bond O, CH2, CH2, CH3. Drawing only the carbon chain, I'll get this. I've just eliminated out the hydrogens and drawn only the carbon chain with this double bond O. So this is my methyl N-propyl methyl. This is my N-propyl ketone. The IUPAC name will be, first we'll use the first rule, that is my longest chain rule. The longest chain is 1, 2, 3, 4, 5. So it will be pentane. Then the shortest number rule is 1 and 2. So this will be pentane 2. And since it's an ketone, it will be one. Pentane 2-one. Option A, pentane 2-one is my correct answer. Question 21. The IUPAC name of diethyl ketone is A. butanone, B. pentane 2-one, C. pentane 3-one, D. butane 2-one. So first we will make a diethyl ketone. A diethyl ketone is ethyl from this side and ethyl from this side. This is my diethyl ketone. This is my one ethyl. This is my another ethyl. 2 ethyl groups, therefore diethyl, and this is my ketone. So now for the IUPAC nomenclature, we will first use the longest chain rule. My longest chain is 1, 2, 3, 4, 5. So it will be pentane. My shortest number rule is 1, 2, 3. And from here also it will be 1, 2, 3. So my shortest number is 3. So pentane 3-one. Pentane 3-one. Option C, pentane 3-one is my correct answer. 22. In the compound R-RC-O, the carboxylic compound is joined to other atoms by A. 2 sigma 1 pi bond, B. 3 sigma and 1 pi bond, C. 1 sigma and 2 pi bonds, D. 2 sigma and 2 pi bonds. So over here, first I'll make this. This is R dash, this is R, this is double bond O. This is my sigma bond, even this is my sigma bond. This bond is again my sigma bond, only this double bond is my pi bond. So if we calculate, I have 3 sigma bonds and 1 pi bond. 3 sigma and 1 pi is an option B, 3 sigma and 1 pi bond. Therefore option B is my correct answer. Question 23. Aldehydes are the first oxidation products of A. any type of alcohol, B. tertiary alcohol, C. primary alcohol, D. secondary alcohol. So if I have to make an aldehyde, this is my aldehyde. So I will need a primary alcohol. This is my primary alcohol. If it will be a secondary alcohol, it will turn out to be a ketone. So always primary alcohols give us aldehydes, whereas secondary give us ketones. Therefore option C, primary alcohol, is my correct answer. Question 24. I have this in H2 and PdBOSO4, where instead of my aryl halide, I have hydrogen to it plus HCl. This is an example of A. Clemenson's reduction, B. Rosenman reduction, C. Wolff-Kishner's reduction, D. Wirth's reaction. So over here in presence of PD and BOSO4, when my aryl halide, the halide, that is the Cl, the halogen, is cancelled out and gives back my original hydrogen. This reaction is known as Rosenman's reaction. Therefore, option B, Rosenman's reaction, is the correct answer. Question 25. Benzene plus. Over here I have an R carbon, that's my carboxylic group with Cl. So this is my alkyl halide with an anhydrous AlCl3 is giving me the, from alkyl halide it is going and becoming an aryl halide. So over here the Cl goes with H and R comes over here. Is an example of A. Friedel-Crafts alkylation, B. Friedel-Crafts acylation, C. Cannizzara's reaction, D. Claison's condensation. The answer is B. Friedel-Crafts acylation. Question 26. The product of the reaction between diethylacetam and acetyl chloride is ACH3COCH3, BC2H5COC2H5, CCH3CHO, DCH3COC2H5. So let's first write diethyl cadmium. Diethyl cadmium is C2H5 twice because diethyl, and cadmium, my cadmium is CD. This reacts with acetyl chloride. So we'll write acetyl chloride CH3COCl. This is my acetyl chloride. This reaction will give me my product as ethyl methyl ketone, that is CH3. This is my methyl, ethyl C2H5. This is my ethyl methyl ketone plus CDCl twice. CH3COC2H5 is my option D. CH3COC2H5. Therefore, my option D is my correct answer. Question 27. Ethyl methyl ketone can be reduced to N-butane by A. Itard reaction, B. Wolff-Kishner's reduction, C. Stephen's reaction, D. Friedel-Crafts acylation. First, we will convert it. So on my reactant side, I have ethyl methyl ketone. We will make ethyl methyl ketone. This is my methyl. Over here, I make my ethyl. This is my ethyl methyl ketone. I will react it with NH2 twice minus H2O. This will give out water. This will form a hydrazone. My hydrazone is C double bond N-NH2. Over here I have my methyl as it is and ethyl as it is. To this, if I add KOH and heat it, it will give me CH3 C2H5 and over here I have CH2 plus N2. This is nothing but 1, 2, 3, 4 carbons in a single chain. This is my N-butane. So from ethyl methyl ketone we have boiled down to N-butane, and this whole reaction is known as Wolff-Kishner's reduction. Therefore option B, Wolff-Kishner's reduction, is the correct answer. Question 28. Which of the following is the mechanism of representative reactions of carbonyl compounds? A. Nucleophilic substitution, B. Electrophilic substitution, C. Nucleophilic addition, D. Electrophilic addition. The answer is C. Nucleophilic addition. Question 29. Acetaldehyde and acetone react with HCN to find the corresponding A. cyanides, B. nitrites, D. cyanohydrins, D. hydrides. I have acetaldehyde and acetone. Both of them are my first aldehyde and ketone. Both of them will react to find cyanohydrins. Option C, cyanohydrins, is my correct answer. Question 30. Which of the following will give the addition product to NaHCO3? A. CH3OH, B. CH3COOH, C. CH3COCH3, D. CH3CH2CH3. So first let's make acetone. That is my CH3, CH3 double bond O plus NaHCO3, which is there in our question. Reversible reaction will give us CH3, CH3 over your SO3Na and over your OH. So this is my acetaldehyde sodium bisulfite. This is my addition product. So on addition, this is my addition product, but which gave this an addition product was this CH3COCH3. Option C, CH3COCH3 is my correct answer.